Hello again. This is Math 0482 coming to you from the College of DuPage. This video is being made on September 7th, and this is the second contribution for this day. And the title of this lecture is Solving Absolute Value Inequalities. Now we're going to learn how to solve absolute value inequalities. Some examples of absolute value inequalities are the absolute value of t less than 6, the absolute value of n plus 2 less than or equal to 5, the absolute value of 3k minus 1 greater than 11. And a final example here is the absolute value of 5 minus 1/2 y greater than or equal to 3. We first discuss how to solve absolute value inequalities that contain a less than or equal to. So let's begin by saying, what does it mean to solve the absolute value of x less than or equal to 3? It means to find the set of all real numbers whose distance from 0 is 3 units or less. 3 is 3 units from 0, and minus 3 is 3 units from 0. So any number between 3 and minus 3 is less than 3 units from 0. And so, for example, if x was 1, it would be 1 is less than 3, and if x is minus 2, the absolute value of minus 2 is less than or equal to 3. Now we can represent the solution on a number line, and here we would put solid dots on minus 3 and 3 and color in all of the numbers that are between those two. And in fact, the endpoints are included as well, so those would be solid dots. We also can write the solution set in interval notation as bracket, meaning closed interval, minus 3, comma 3, and another bracket. The brackets indicating that the negative 3 and 3 are both included in the solution set. Let's build upon our example to talk about the general procedure to solve this, where p is an expression. And so now we're talking about, how do you solve the absolute value of p less than or equal to k, or how do you solve the absolute value of p less than k? So we're letting p be an expression, and we'll let k be any positive real number. To solve the absolute value of p less than or equal to k, we solve the three-part inequality. Minus k is less than or equal to p is less than or equal to k. And note that less than may be substituted for less than or equal to. Please realize that this is saying the absolute value of p is less than or equal to k, or the absolute value of p is less than k. Okay, so let's solve a simple example. If we said the absolute value of t was less than 6, and if I ask you to graph the solution set on a number line and write the answer in interval notation, how would you solve it? Well, we must find the set of all real numbers whose distance from 0 is less than 6, and so that means that that minus 6 is less than t is less than 6. We represent this on a number line. Now at minus 6 and plus 6, we have an open circle because those aren't included, because this does not allow equal sign. So we now can color in the numbers that are between those two empty open circles. So we can write the solution set in interval notation as parentheses minus 6 comma 6. Any number between minus 6 and 6 will satisfy the inequality. Let's do 3 more examples. The next example we're going to do, and again in each case you're to solve each inequality, to graph the solution set, and describe the answer in interval notation. So suppose I give you the problem that we're going to solve. It is the absolute value of n plus 2 is less than or equal to 5. This means we must find the set of all real numbers n such that n plus 2 is less than or equal to 5 units from 0. So to solve the absolute value of n plus 2 less or equal to 5, we must solve the three-part inequality. Minus 5 is less than or equal to n plus 2 is less than or equal to 5. To solve this, we subtract 2 everywhere, from the left term, from the middle term, and from the right term. So minus 5 minus 2 is minus 7, is less than or equal to n plus 2 minus 2 is n, is less than or equal to 5 minus 2. So when you do the calculations, you get that minus 7 is less than or equal to n, is less than or equal to 3. So the number line representation of this is we would start at minus 7, color it in because it can be equal. We would go to 3, color it in because it can be equal, and any numbers between these on the number line would be solutions. In interval notation, we can write the solution as bracket, because the minus 7 is included, bracket minus 7 comma 3 bracket. And again, any number between 7 and 3, and including the endpoints, will satisfy this inequality. Let's do a second problem, and this next one is the absolute value of 4 minus 5p is less than 16. So we're going to solve the three-part inequality. So we will write minus 16 is less than 4 minus 5p is less than 16. Now we're going to work to get p in the middle. And so what we're going to do is we're going to have to subtract 4 everywhere. So we subtract 4 from minus 16, getting minus 20, from 16, getting 12. And now we know that in the middle, when we subtract 4, we're left with minus 5p. So now we have minus 20 is less than minus 5p is less than 12. We did that by subtracting 4 everywhere. But now we're going to find out about p. We have to divide all the way through by minus 5. When you divide by minus 5, you change the directions of all the inequality symbols. And so we get minus 20 divided by minus 5 gives us a positive 4, is bigger than p, and that in turn is, and it's just p in the middle now, and that in turn is bigger than minus 12 over 5. So this inequality means that p is less than 4 and greater than minus 12 over 5. So we can rewrite this as minus 12 over 5 is less than p is less than 4. So on the number line, the solution will start at minus 12 over 5 with an open circle. It will go all the way to 4, and there will be an open circle on 4, and it's all the numbers that are in between the two. In interval notation, we will write parentheses minus 12 over 5, comma 4, end of parentheses. Here's a U-try for you. I'm going to ask you to solve two inequalities. The first, and graph the solution set and write the answer in interval notation. So problem A is the absolute value of 6k plus 5 is less than or equal to 13. The second problem is going to be the absolute value of 5 minus 2w is less than 9. Please write both of these problems down, and once you have written them down, you should pause the video and solve both of them, and we'll see how you do. Please write them down now and pause the video. Let's see how you did. So the answer to U-try 2 should be in interval notation, bracket minus 3, comma 4 over 3, end of bracket. And for part B, it should be parentheses minus 2, comma 7. And the graphs would reflect those intervals on the real number line. Now we're going to turn our attention to a different problem, and please understand the difference. This is going to be solving absolute value inequalities containing greater than or equal to. Let's discuss this a little bit. To solve, the absolute value of x being greater than 4 means to find the set of all real numbers whose distance from 0 is 4 units or more. So 4 is 4 units from 0, and minus 4 is 4 units from 0. So any number greater than 4, or, and the number, and the word is or, less than minus 4, is more than 4 units from 0. It is important that you say more, that you're using more, and that means that these are going to be disjoint sets, and it's going to be an or, the word or, in between them. And that means that in this case, we're talking about the absolute value of x being less than or equal to minus 4, or the absolute x greater than or equal to 4. In interval notation, we say or using the union sign in mathematics. And so we write minus infinity up to minus 4, bracket, because the endpoint is included, union, bracket 4 to plus infinity. So the procedure to solve the absolute value of p being an expression greater than or equal to k, or p being strictly greater than k, is the following. So if p is the expression, and if k is a positive real number, to solve the absolute value of p being greater than or equal to k, we have a compound inequality. That means that the expression p is greater than or equal to k, or p is less than or equal to minus k. So if we were to solve the absolute value of r being greater than 2, we must find all real numbers whose distance from 0 is greater than 2. And that means that r is greater than 2, or r is less than minus 2. And so we put open circles, in this case, around 2 and minus 2, and we go from minus 2 all the way down to minus infinity, and from 2 all the way to plus infinity. So in interval notation, we write parentheses, minus infinity, comma, minus 2, close parentheses, union, 2, comma, infinity. And any number in the shaded regions will satisfy the inequality. Let's do 2 more examples with more complicated expressions for p. So let's first solve the inequality. The absolute value of 3k minus 1 is greater than 11. This means we want to find the set of all real numbers k such that the absolute that 3k minus 1 is more than 11 units from 0 on the number line. So we will solve the compound inequality. 3k minus 1 is greater than 11, or 3k minus 1 is less than minus 11. And we solve them separately, and the or is always between them. So going to 3k minus 1 greater than 11, we will add 1 to get 3k is greater than 12. And dividing by 3, we will get k is greater than 4. Or, on the other side, we started with 3k minus 1 is less than minus 11. When we add 1 to both sides, we get 3k is less than minus 10. And that means k is less than minus 10 over 3. So you see we have k is greater than 4, or k is less than minus 10 over 3. So on a number line, we will go from an open circle around 4 to positive infinity, and we'll go from an open circle around minus 10 over 3 to minus infinity. And if we were to write this in interval notation, we would write minus parentheses, minus infinity, comma, minus 10 over 3, close the parentheses, union, parentheses 4, comma, infinity. Let's do another problem. And the second problem I'm asking you to consider is I have the absolute value of c plus 6, close absolute value, is bigger than, excuse me, I'll say it again. The absolute value of c plus 6, end of absolute value, plus 10 is bigger than or equal to 12. I've got to get this in the form where I just have the expression being then a number, so I have to subtract the 10 from both sides, turning this into the absolute value of c plus 6 is bigger than or equal to 2. This says that c plus 6 is bigger than or equal to 2, or c plus 6 is less than or equal to minus 2. If c plus 6 is bigger than or equal to 2, c is bigger than or equal to minus 4, or if c plus 6 is less than or equal to minus 2, c is less than or equal to minus 8. And so the solution set is in interval notation, minus infinity up to minus 8, bracket, because the minus 8 is included, union, that's the or, going from bracket minus 4 up to infinity, parentheses. And on a number line, it would start at minus 8, color in the circle, go to minus infinity, and we would go to minus 4, color in the dot, and go to plus infinity. Here are two U-tries for you to try. I would like you to think about graphing the solution set and writing the answer in interval notation. Please write both of these down and then pause the video and solve them, and I will share the answer with you. And this is called U-try 4 in these notes. The first problem is the absolute value of 8q plus 9 is bigger than or equal to 7. That's the absolute value of 8q plus 9 is bigger than or equal to 7. The second problem, called B, is the absolute value of k plus 8, end of absolute value, minus 5 is bigger than or equal to 9. Please write those down carefully, pause the video, and try to solve. Pause the video now. Let's see how you did. And so the answer to U-try 4 for part A will be minus infinity up to minus 2 with a bracket, union, minus 1/4 with a bracket, comma, infinity. And so this would be starting from minus 1/4 on the number line, going all the way to plus infinity, and the minus 1/4 would be colored in, and the minus 2 on the same number line would be colored in, and you go to minus infinity. That was for problem A. For problem B, you go from minus infinity up to minus 22, bracket, it is included, union to stand for or, bracket 6, comma, plus infinity, parentheses. And so on the number line, you would put a darkened in circle at minus 22 and go to minus infinity, and you would put a bracket, a closed circle rather, around 6, and you would go to plus infinity. Now it's important to understand what the absolute value inequality means before trying to solve it. These are considered to be special cases. The first example we'll talk about is, suppose I ask you to solve the inequality, the absolute value of z plus 3 is less than or equal to minus 6. Let's think carefully about this inequality, the absolute value of z plus 3 less than minus 6. This says that the absolute value of z plus 3 is less than a negative number. Well, since the absolute value of a quantity is always 0 or positive, this has no solution. The solution set would be the null set. Let's look at another example. Suppose that I said the absolute value of 2s minus 1 was bigger than or equal to 0. The absolute value of 2s minus 1 bigger than or equal to 0 says that the absolute value of a quantity, 2s minus 1, is greater than or equal to 0. But an absolute value is always greater than or equal to 0. So any value of s will make this inequality true. So the solution set consists of all real numbers, which we can write in interval notation as minus infinity to plus infinity in parentheses. It's the entire number line. In the last example, we have the absolute value of 4d plus 7, end of absolute value, plus 9 is less than or equal to 9. Now, when we isolate the absolute value expression, we get, by subtracting 9 from each side of the inequality, we get the absolute value of 4d plus 7 is less than or equal to 0. Now, the absolute value of a quantity can never be less than 0, but it can be equal to 0. So the only answer is going to happen when we solve 4d plus 7 equal to 0. So if 4d plus 7 equals 0, 4d equal minus 7, that means that d equal minus 7 over 4. So there's only one answer to this problem, minus 7 over 4. Here's a final example for you to try. See what happens if you consider the absolute value of 3 minus 4x into the absolute value less than or equal to 0. Pause the video and see how you do. And the answer you should have gotten is x is equal to 3 over 4. In closing, remember, time is precious. Each day must count. Do the math. It will make you strong. I look forward to seeing you next week.